Hello everyone, welcome in channel of Mr. Statistician. Today we solve IIT JAM questions. Let's begin. Question is, let x and y are independent random variables having normal 0, sigma 1 square and normal 0, sigma 2 square distribution respectively, where 0 is less than sigma 1 is less than sigma 2, then which of the following statement is or are true? This question is a MSQ type, that is a answer of this question is one or more is true. So to solve this question, to need remember these two results. If x and y are invariant independent normal random variable, then x comma y has bivariate normal distribution, that is x and y are invariant normal random variable and both are independent, then distribution of x comma y is bivariate normal. Second result is, in bivariate normal, any two linear combination of x comma y are independent if covariance between these two linear combination is 0. That is, x comma y follows bivariate normal, then linear combination of x comma y, any two linear combination, these are independent if covariance between these two linear combination is 0. Here we given that x follows normal with parameter 0, sigma 1 square, y follows normal with parameter 0, sigma 2 square given, and here given that x and y are independent, x comma y are independent. So we first see x plus y and x minus y are independent. Here see that x and y are invariant normal and x and y are independent. By first result implies that x comma y follows bivariate normal distribution. So second result implies that x comma y follows bivariate random normal distribution, then any two linear combination of x comma y. Here see x plus y, which is a linear combination of x comma y, and x minus y also linear combination of x comma y. These two are linear combination of this, and these two are independent if covariance between these two linear combination, that is x plus y comma x minus y, which is equal to 0. So let's check this covariance is 0 or not. So which is equal to covariance between x comma x minus covariance between x comma y plus covariance between y comma x minus covariance between y comma y, which is equal to covariance between x comma x, which we know covariance between x comma x is variance of x minus covariance between x comma y. Here covariance between x comma y and covariance between y comma x are similar, that is covariance between x comma y minus variance of y, which is equal to, here variance of x is sigma 1 square. Here we both cancel covariance between x comma y and y comma x, minus variance of y is sigma 2 square here, which is not equal to 0 because here sigma 1 square is less than sigma 2 square. This 0 if sigma 1 square equal to sigma 2 square, which is not possible. So first answer is false. So we need to check second answer. 2x plus y and x minus y are independent if 2 sigma 1 square equal to sigma 2 square. Here also see 2x plus y which is linear combination of x comma y, and x minus y, which is also linear combination of x comma y, which is independent if covariance between 2 is 0 by second result. So we check covariance between 2x plus y comma x minus y, which is equal to covariance between 2x. So we write 2 is outside the covariance, x comma x minus 2 covariance between x comma y plus covariance between y comma x minus covariance between y comma y. So which is equal to 2 into covariance of x comma x is variance of x, 2 into variance of x minus 2 into covariance between x comma y, so plus covariance between y comma x is equal to x comma y minus variance of y, which is equal to 2 into variance of x is sigma 1 square, minus here x and y are independent, so covariance are 0 minus sigma 2 square here, which is equal to 2 sigma 1 square minus sigma 2 square, but here given that these two are independent, that is here this equal to 0 if 2 sigma 1 square minus sigma 2 square is equal to 0. So here see that these are independent if 2 sigma 1 square equal to sigma 2 square equal to 0. So second answer is true, that is B answer is true. So also this question is of MSQ time, so we need to check all answer. So see, x plus y and x minus y are identically distributed. We know that identically distributed means distribution of x plus y and x minus y are same. Here x follows normal with parameter 0 comma sigma 1 square, y follows normal with parameter 0 comma sigma 2 square, x and y are independent. Here x plus y, so we know that x follows normal, y follows normal, so x plus y follows normal with parameter is mu1 plus mu2, that is 0 plus 0 comma x and y are independent, therefore their variance is sigma 1 square plus sigma 2 square, that is by additive property of normal distribution, that this distribution is equal to normal 0 comma sigma 1 square plus sigma 2 square. So we need to check distribution of x minus y. Here we know y follows normal 0 comma sigma 2 square, so minus y follows normal with parameter 0 comma sigma 2 square. We know that if x follows normal with parameter mu comma sigma square, then ax follows normal with parameter a mu comma a square sigma square. So here a equal to minus 1 because here minus y, so minus y follows normal with parameter a mu means 0, minus 1 into 0 is 0 and minus 1 square is 1 square into sigma 2 square, because here sigma is sigma 2 square. So this by this result, so we need distribution of x minus y which is equal to x plus of minus y. So we know x follows normal 0 comma sigma 1 square and minus y follows normal 0 comma sigma 2 square. X and y are independent. This implies that x and minus y are also independent. So by additive property of normal distribution, x minus y follows normal with parameter is 0 plus 0 minus y and x 0 plus 0 comma sigma 1 square, here sigma 2 square, sigma 1 square plus sigma 2 square, which is equal to normal 0 comma sigma 1 square plus sigma 2 square, which is x minus y distribution. So here check x plus y follows normal 0 comma sigma 1 square plus sigma 2 square and x minus y follows normal 0 comma sigma 1 square plus sigma 2 square. So distribution of both x plus y and x minus y are same, so x plus y and x minus y are identically distributed random variables. So we need to check fourth answer is true or false. Here in fourth answer we asked that x plus y and x minus y are independent if 2 sigma 1 square equal to sigma 2 square. Here we know x follows normal 0 comma sigma 1 square, y follows normal 0 comma sigma 2 square, x and y are independent. So by first result implies that x comma y follows bivariate normal distribution, so we not need parameter of bivariate normal. So second result implies that linear combination of x comma y, that is x plus y is a linear combination of x comma y, and 2x minus y, which is also linear combination of x comma y. So these are independent if covariance between x plus y and 2x minus y, that is covariance between these two linear combination is 0. Let's check when this covariance is 0. So which is equal to covariance between, so we write 2 is outside covariance between x comma x minus covariance between x comma y plus covariance between 2 into covariance between y comma x minus covariance between y comma y, so which is equal to 2 into variance of x, because covariance between x is variance of x, minus covariance between x comma y. So here we write plus 2 into covariance between y comma x is similar to x comma y minus variance of y. Here we know 2 variance of x is sigma 1 square, covariance is 0 of because x and y are independent, minus sigma 2 square, which is equal to 2 sigma 1 square minus sigma 2 square, which is equal to 0 if this term is 0. So this term is 2 sigma 1 square minus sigma 2 square is equal to 0, that is 2 sigma 1 square, which is equal to sigma 2 square. Here see, check, 2 sigma 1 square equal to sigma 2 square. So the answer is true.